Hi, everyone. So let's take a look at the next conic section that we're going to talk about. The previous conic section, we talked about circles, and so this new one is called the ellipse. And so if you look at an ellipse, it looks very similar to a circle, and that's kind of roughly part of this definition of what an ellipse is. So if you remember, a circle is the set of points a fixed distance from one point, where everything's equidistant from the very center. Now, an ellipse is basically a stretched version of a circle, but now it's all equidistant from two fixed points that are within this ellipse. Okay, and so you can read over this definition, and we've got a bunch of new vocabulary. You can see all of the highlighted words there are new vocabulary that we're going to talk about. And so let's read through, we're going to read through this paragraph here and start to sketch out an example of an ellipse. Okay, so I'm going to draw a coordinate plane here. And what you're going to notice is based on how the circle gets stretched, we can either have a horizontal ellipse or a vertical ellipse. Okay? And so let's read over some of this vocabulary here. The major axis is the segment that contains the foci and has its endpoints on the ellipse. Okay? And so now let's label our major axis. And so we have a horizontal major axis if we have a horizontal ellipse, and we have a vertical major axis if we have a vertical ellipse. And on the major axes here, on either ellipse, we have our foci. And now our foci are those 2 points that all of the other points on this ellipse are equidistant from. And so we can kind of label them here. I don't mean to put that in the center here. So let's redraw this. And so we've got the foci. And I'm going to call this one F1 and this one F2. And again, for the vertical ellipse, they're always on that major axis. So we've got foci 1 and foci 2. Okay? And so then we have the midpoint is the center of the ellipse, and so that's our center here. Okay? The minor axis is perpendicular to the major axis at that center point. So then we've got a minor axis here. For a horizontal ellipse, and a minor axis here for our vertical ellipse. And on this minor axis, we have co-vertices, and on the major axis, we have vertices. So we can see our next highlighted part, it says the vertices of an ellipse are on the major axis. And so let's get a different color here. We've got a vertex here and a vertex here. Same thing with our vertical ellipse. I've got a vertex here and a vertex here. And these vertices, we use the value of A to represent our vertices. So this would be negative A comma 0, and this would be A comma 0, right? Because it's moving left or right, nothing up and down on the horizontal ellipse. On the vertical ellipse, we're moving up and down, so it would be 0 comma A and 0 comma negative A. Okay, but you can notice it's symmetric from the center. And so then on our minor axis, we have our co-vertices. And so that's going to be the endpoints of on the minor axis. So here we've got a co-vertex. And here we've got a co-vertex on our minor axis. Same thing over here, we've got a co-vertex and a co-vertex. And for our co-vertices, we use the variable b to represent the points at our co-vertices. So this would be 0, comma b, and this would be 0, comma negative b, since that's going up and down. Here we've got negative b, comma 0, and positive b, comma 0, since those vertices move left and right. Okay? And so a lot of different pieces of new vocabulary, a lot of key features when we draw these ellipses. And the vertices, the co-vertices, these axes, and our foci help us draw what our either horizontal or vertical ellipse is going to look like. And so you can see at the bottom there are those same key vocabulary words. Okay? And so let's just jot down a couple things to summarize it all together. What's really important to notice, and we haven't looked at this yet, is our equations. Okay, just like you know the equation of a line is y equals mx plus b, we've got a certain equation for horizontal and vertical ellipses. And so we're going to highlight them here. And what I want to point out, so our horizontal ellipse, the equation of a horizontal ellipse is x squared over a squared plus y squared over b squared equals 1. And then our equation for a vertical ellipse is x squared over b squared plus y squared over a squared equals 1. And what's really important to note is where that a value is, okay? The a value is always our largest number, okay? And so let's notice that, and that's what this means right here. So a is always the largest, and that's how we're going to know whether we have a horizontal ellipse or a vertical ellipse, because notice it comes first here. If that larger value comes first, if it's with the x squared, then I have a horizontal ellipse. If that larger value comes second and it's with the second fraction, the y squared, then I know it's a vertical ellipse. And so you can see based on whether or not we have that a value first or second, it's going to dictate whether our major axis is horizontal or vertical. And you can see just how we labeled in our picture, in our graph, our vertices use the a value and our co-vertices use the b value. And then our foci, which are on that major axis, we use the c value to identify a foci. Okay, and I don't think we had that in our picture up here. So let's add that in. We have a negative c comma 0, or positive c comma 0, or we have a 0 comma c, 0 comma negative c for our foci. Okay, and how we find our foci, that's really important, is we use a version of Pythagorean theorem. We're going to say how we find our foci is using the formula c squared equals a squared minus b squared. Okay, and that comes from noticing we do have a triangle within our points that are along the ellipse using those foci. Okay, so really important, that's how we find our foci using that formula. Okay, let's dive into our first problem, our first example. I'm going to zoom out a bit here so we can see everything. Okay, it says, what is an equation in standard form of an ellipse centered at the origin, so centered at 0, 0, with the vertex negative 6, comma 0. I'm going to jot this stuff down. With the vertex of negative 6, comma 0, and a co-vertex of 0, comma 3. And so now right away, I notice that my vertex is in the x value. And so that tells me that I have a horizontal ellipse. Because if you go back and think about this visual, when my vertices are moving left and right, I have a horizontal ellipse. Okay? And so I know my covertex, that's going up and down, that's showing how like wide this ellipse is. And so as soon as I know we're writing a horizontal ellipse, let's start to write that equation. So I know it's going to be x squared over a squared plus y squared over b squared equals 1. And so my vertex tells me my a value is 6, so my a squared is going to be 36. And my covertex tells me my b value is 3, so my b squared value is going to be 9. And so now I know the equation of this ellipse is going to be x squared over 36 plus y squared over 9 equals 1. And that is the equation of this ellipse when I'm given the vertex and the covertex. Okay, let's check out problem number 2. What are the foci of the ellipse with the equation 25x squared plus 9y squared equals 225? And then we want to graph the foci and the ellipse. Okay, so let's write down this equation. We've got 25x squared plus 9y squared equals 225. Now, if you go back and look at the equation of ellipses, we have to have it set equal to 1. So you notice right there, they're always set equal to 1. And so we need to get this equation set equal to 1. And we're going to do that by dividing everything by 225. Because if we divide everything by 225, we are going to have it set equal to 1. And then I can reduce these fractions. 25 over 225 is the same thing as 1 over 9 if I reduce that fraction. So I'm going to have x squared over 9, plus then I have 9 over 225, which is the same thing as 1/25. So that's going to be y squared over 25. And so that tells me a whole bunch of information, right? This is now I know my a value. Sorry about that. Because my a value is always the largest number, I know that my a squared is 25. I know it's second in the fraction, so I know this is going to be a vertical ellipse. And I know my a is going to be 5 then. Then here is my b squared, so my b is 3. And so that helps me graph this a whole bunch. We can also now find our foci. Our foci we know is going to be using the formula c squared equals a squared minus b squared. So I'm going to do c squared equals my a squared is 25 minus 9. So my c squared equals 16. So my c equals 4. Okay, so much information we just found. And let's just write it out so we can organize everything that we just found. So I know I have a vertical ellipse because the a value was under the y. That tells me that my vertex, my vertices are going to be at the on the vertical axis here. And so they're going to be at 0, plus or minus 5. My covertices are going to be at that b value, and they're going to go left and right. So they're going to be at plus or minus 3, 0. And then my foci are going to be along that major axis, with the vertices. So they're going to be at 0, plus or minus 4. And now's the fun part where we just get to put this all together and graph it. So my vertices are at plus or minus 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Notice it's going to start to make sense to be a vertical ellipse because it's going to be stretched long ways. My covertices are left and right. They're at 3 and -3. And then my foci are along the same axis as my vertices, and they're at 4 and -4. And so then we can connect our vertices and our covertices and get our vertical ellipse with our foci graphed also. Okay, great job on that one. We're going to just do one more. So it says, what is the standard form equation of the ellipse shown? Okay, so right away I see a horizontal ellipse, so I know the equation is going to be x squared over a squared plus y squared over b squared equals 1. And then I'm going to use this information that was given. I can tell my vertices, my vertex are at plus or minus 8, 0. So that tells me my a value is 8. So that's helpful. And then they also give me my foci are at plus or minus 5, 0. So that tells me my c value is 5. My b value, my covert vertices, are 0 plus or minus the b value. And I don't know what these points are. It looks like it's at -6, but before I drew all over it, you can see it's not really clear if it is actually -6 or not. So I need to figure out what my b value is. And we're going to go back to using our version of Pythagorean theorem that will help us find the covertex here, b value. So it's c squared equals a squared minus b squared. I know my c squared is 5, so I have 25 equals my a squared, which is 64 minus b squared. I'm going to subtract 64 over. And then I'm going to get 39 equals b squared. Okay, so now I know 39 equals b squared, which is all I need to write the standard form equation of this ellipse. I've got x squared over my a squared, 64, plus y squared over my b squared, which is 39, equals 1, is the equation of that ellipse that's shown. Okay? So guys, here was our example and our lesson on how to graph and write equations of ellipses. I hope it was helpful. If you have any questions, please let me know. Great job, guys.